We have an example here where we're going to think about comparing exponential and logarithmic functions. Our exponential function has an x in the exponent. That's necessary for it to be exponential. We need a variable where the exponent would be. And then we have our logarithm function, and where we're trying to get the desired result. In other words, we're trying to get the exponent for 2. Okay? So we make a table and we say some reasonable values where x is negative. Now that won't make f of x negative, but it will make it smaller. The more negative you go, the smaller it will be, but it'll still be positive. It'll still be a positive 2 to the negative 2. So it'll just be small, like 1/4. That's pretty small. And then a little bigger, 1/2. And then we put in 0 and we get 1. And so these are reasonable answers. You can see that it starts slow and it takes off. Okay. And then we're going to take a look. You say, because g of x is equal to the log base 2 of x is the inverse function of the original function. Well, it's a reflection through the line. It's a reflection through the line y equals x. So once we have the graph of this that we were talking about, where it starts off small and it never quite goes negative, it just gets close to 0, and then it takes off. The logarithm is the reflection through the curve, or through the line, y equals x. Okay? So if I want to draw the graph of the logarithm, all I have to do is reflect it through that line. Okay? And that's what we're going to do. So let's see. They gave us 3. So we're going to say, okay, what are some... So you see we're going to use the graph of f to sketch the graph of g. And you say, good, because I don't know how to find the log base 3 of things yet. Okay, well, that's all you don't need to know. We're just going to reflect it. So let's see, some reasonable values for x when it comes to f of x. So we'd say x and f of x. What would those values be? Well, let's see. We do the same thing. -2, -1, 0, 1, 2. I guess we could say 3. All right, so let's see what happens. When I put in a -2, I get 1/9, right? I get, 3 to the 2 is 9, but then negative means put it on the bottom. And 3 to the -1, that's that's 1/3. Anything to the 0 is 1. Anything to the 1 is itself. Anything to 2, I get squared. And then 3 to the 3rd is 27. So when I graph this, I would say at -2, I'm at 1/4. I'm close to the bottom. At -1, I'm not much better. I'm at 1/2. At 0, I'm at 1. Okay. At 1, I'm at 3. At 2, I'm at, at 1, I'm at 3. Sorry about that. Here, can I undo that? Can I? Oh, no, I can't. Okay, let's do this. There we go. At 1, I'm at 3. I was supposed to be at 3. At 2, I'm at 9 up here somewhere. At 3, I don't have room to show you that. Okay, so I'm really close to 0, but never negative. That's not the greatest graph in the world, is it? Let me try this again. Really close to 0. And then it takes off. Okay. And I would like to know where this line is, y equals x, because I need a reflection through that. Okay. So what's the reflection through this line? Well, the reflection through this line would be, like that. Okay, so here's g of x equals to the log base 3 of x. Okay, and I know that because I just had to reflect f of x is equal to 3 to the x. And I'm just reflecting it through this line, y equals x. That's all I have to do. Can you kind of see how that's reflected? I hope you can see. If I did it right, and that's arguable, But the distance across this line should be the same, you know. Should be the same. Wherever I go, it should be the same. Okay?